Next, just write about S3. Okay, so S3, like S3 here, n is 3, so it has n factorial element that is equals to 6. So S3 is the permutation group defined on the set having elements 1, 2, 3. Okay, so let's just analyze the elements of S3 by having the actual maps. Okay, so I have just drawn the diagrams. So first case is like the very basic case, like how we can map these three elements to these three elements such that the mapping is bijection. Okay, so first one is like the very basic case, like 1 is mapped to 1, 2 is mapped to 2, 3 is mapped to 3. Okay, next possibilities, we have mapped 1 to itself and these are cross multiplied. Okay, second possibility is like we have mapped 2 to itself, then these are cross multiplied. Okay, next one is we have mapped 3 to itself, then these are cross multiplied. Okay, next case is 1 is mapped to 2. Okay, let's say 2 is mapped to 3 and 3 is mapped to 1. Yes, this is also the possible case. Next case is we have mapped 1 to 3, then 2 to 1 and 3 to 2. Yes, after this there is no more possibility such that the mapping is bijection. You can check it also. Okay, so we can write these mappings as, first one is like 1 to 1, 2 to 2, 3 to 3, that is identity. Okay, here like okay, let me just write first the permutation notation. First one is 1 to 1, 2 to 2, 3 to 3 first. Okay, next we had for this we have 1 to 1, 2 to 3 and 3 to 2. Okay, for next one, this one, we have 1 is mapped to 3, 2 is mapped to 2 and 3 is mapped to 1. Okay, next we have this, we are having as 1 as to 2, 2 is to 1 and 3 to itself. Okay, next we have 1 to 2, 2 to 3 and 3 to 1. Yes, and for last we have 1 to 3, 2 to 1 and 3 to 2. Okay, so we got the permutation representation. Okay, next we will write these permutation in the form of cycle notation, that would be easier to understand and analyze. Okay, so first is basically identity. Okay, next one is this, so we can write it as like 1 is mapped to 1, no need to write this. Okay, second is we have 2 to 3, 2 to 3 and 3 to 2, 2 to 3 and 3 to 2. So that is the cyclic notation of second. Okay, next we have 1 to 3, basically 1 to 3, then 2 to 2, no need to write this, then 3 to 1, 3 to 1 and 1 to 3. So this is the cyclic notation. Next we have this 1 to 2, 2 to 1 and 3 to 3. No need to write 3 to 3, just we write 1 to 2 and 2 to 1. Basically 1 is mapped to 2, 1 is mapped to 2 and 2 is back mapped to 1. So this is the cyclic notation of this. Next we have this, we can write it as 1 to 2, 1 to 2, 2 to 3, 2 to 3. Yes, 1 to 2. Okay, 1 to 2, 2 to 3 and 3 to 1, 3 to 1. So this is the cyclic notation. Next we have this, basically 1 to 2, 3, then 3 to 2, 3 to 2, 2 to 1, then 2 to 1. So this is the cyclic notation. Okay, so basically in S3 we get the 6 elements, such as, let me just write it clearly. S3 has, basically order of S3 is 6 and it has elements like what? It has identity, okay, 2 3, 1 3, 1 2, 1 2 3 and 1 3 2. See, so these are the only possible elements in S3. Okay, and please don't forget, like once you are writing these elements, basically the cyclic notations, don't add commas in between. There is no comma because it is a cyclic notation. We just write it as 2 3. Basically 2 is mapped to 3. once we are adding basically commas in between, then it will become set on other things, and no, don't add commas in between. Okay, like one of you commented in the last video, right? Is like one, I guess the thing was like 3 to 1 is possible. 3 to 1, basically 3 to 1 is I guess 3 to 1 is the basic possible element in S3 or not. Okay, so don't add commas in between, because once you are having cyclic notations, there is no comma, because it denotes the mapping, not the elements, right? So this is the way you can get the elements of S3, and for other like S4 and S5 also. Okay,